You were, and I thought you were.
Hi, TA and Professor. We are from Group 2. Our team comprises of myself, Sucharita, Nalluri Sivakrishna, Gogineni Sai Kumar, Racha Manish, Yerlagadda Srinayana, Pokaral Sandesh, and Hassan and Lofty Nida. Today we are here to discuss on the project implementations of the classic search algorithms. So we would like to go further and start with what's the travel map which is given to us. The travel map, these are the nodes. So the ones in the circles are the nodes, and the node distance is given by the black number which is present here, and the red color number describes the heuristic cost function. So that this describes the heuristic value. So we are considering this travel map, and we have implemented 5 different search algorithms, and we would like to present one by one. The first algorithm we would like to present is the depth first search algorithm. So it is used to traverse the nodes by always expanding the deepest nodes first. So it goes until the to the deepest level until it doesn't find any successors or the child nodes. So as these nodes are being explored, they are marked as visited so that they doesn't reappear again in the final output. And next, the search goes to the next deepest node until that all the successors become unvisited. So this depth first node basically uses last in first out data structure. So we are going to, in my program, I have used Stack to implement this depth first search algorithm. So the algorithm goes this way. First, for all the nodes, we have made a list of adjacent neighbors, like for each of the node, what are the adjacent neighbors, and then R is the root node, which the user is going to get as the input. So for all the nodes, we are going to mark them as not visited, and then we are going to take an empty stack and push the root node into it. And as long as the stack is not empty, we are going to do a loop, like get to the top of the stack and pop out the first element. If that root node is not visited, we are going to set it as true, and that we are going to add it to the DFS output. And then we are going to loop through all the neighbors that we had added for this root node. And if that neighbor is not visited, then we are going to push it into the stack. So this way, all the child nodes of the root node is going to get added one after the other. And once all the child nodes are added, then we are going to stop. And then again, we are going to go back and go to the top of the stack and pop out the last child node. So this way, we are going to iterate until there are no other visited nodes. So this is the basic algorithm of depth first search. The same thing is being shown in the flowchart. So we are going to start, determine the nodes in what are the nodes in the travel map, and then we are going to determine what are the neighbors for each of the nodes, and then we are going to set the root value, like ask the user, which is we are going to get from the user, like what's the start node, and then we are going to check whether the user entered input is present in the valid list of nodes. If it is yes, then we are going to mark all the nodes as unvisited, then create a stack, and then push the root node into the stack, and we are going to check if it is not empty, get the top value of the stack as root, and then pop out the value. And then if this root is visited, set the output with the visited root, and then update the root value as visited. And one another thing we have to do is traverse through all the child nodes. And then if the neighbor is not visited, then we are going to push that neighbor into the stack. So this is the basic flowchart and algorithm of DFS. And I have written this code in Java, and then I have used the IDE as NetBeans. And this is my output when I have taken the node A and as the starting node, and all the nodes that are traversed are being shown here. So like this, I have shown like 5 basic nodes that were mentioned in the project, A, B, K, S, Y, and these are the output nodes. I would just like to go and run my code. So I have a DFS algorithm project, and then I'm going to run the DFS search Java. And the code is compiling. So it's asking me enter the start node from the nodes A, B, D, E, F, G, H, J. I can enter any of the node. And that's going to give me the list of all the nodes visited in the required format. So we can even go and try for all the different nodes. So this code works appropriately as the professor has taught in the class. So I think we are good with the DFS implementation using Stack, using Java as the programming language. And my friend would continue on the next algorithm, that is BFS, breadth first search.
Yeah, hi. Now here I am going to explain on breadth first search, BFS. So here the best breadth first search is a traversal algorithm traverse a graph in a breadth-wise manner and store the visited nodes in a queue. And here we follow the queue. So it uses a queue to store the nodes of each level whenever they are visited. So here the visited nodes will be stored in the form of a queue. Then these nodes are visited one by one after, then the adjacent nodes are visited. So first level of the nodes are visited, and then the adjacent nodes, and then it will go to the child nodes. So in this BFS travels, one node is selected as a starting position. So the selected node is visited and saved in a queue. And now this is a simple form of overview of BFS algorithm I'm going to explain over here. So when we select one node as a starting node, it will visit it and it will save it in a queue. Then it will traverse to the adjacent nodes of a starting node and save this. Once it visited the adjacent visit the unvisited vertices and save it in the queue. If no adjacent vertex is found, remove the first vertex from the queue and traverse until the queue is empty. So the real time of BFS algorithm is used in the real time applications are like unweighted graphs. BFS algorithm can easily create the shortest path and a minimum spanning tree to visit all the vertices of the graph in the shortest time possibly with high accuracy. And P2P networks, where it can be implemented to locate all the nearest or neighboring nodes in a P2P network. This will find the required data transfer, and many more applications we use. So now here I'm going to explain on rules of BFS algorithm. So here a queue, what is queue? Like it's first in first out, the method it follows. So here the queue is the data structure is used by BFS. So you can mark any node in the graph as a starting node and start traversing the data from there itself. And BFS traverses all the nodes in the graph and keeps dropping them as they are completed. And it visits an adjacent unvisited node, mark it as done, and insert it into a queue, and removes the previous node from the queue in case no adjacent node is found. So now, like BFS algorithm iterates until all the nodes in the graph are successfully traversed and marked as completed. So there are no loops caused by BFS during the traversing of data from any node. So here, this is the pseudocode. Let we consider a function of BFS with G and A as a node and G is a graph. So let Q be the Q. I mean, as a variable name for the Q is capital Q. So now we are inserting the first node in Q until all its neighbors nodes are marked. Now mark A is visited, and from here it will remove all the nodes that got visited. So it will now we will store all the processed nodes in V, and from here we will see like if there are any non-visited nodes. If there are any non-visited nodes, then it will get visited, and once they are all got visited, then it will store in W. Further, it get into its neighbor node. I'm sorry. So here is the flow chart. Yeah. So first first insert the node at the starting node. Then here is the node into stack. Then is check whether the queue is empty or not. If yes, then it will end the program, or else then it will remove the node from the queue then it will go to the point to at first adjacent node. From here, if there is any, if it is the that adjacent node is the last one, then it will go to check whether the queue is empty or not, or else it will go to the node which is either whether it's already visited or not. If that node is already visited, then it will go to the next node of the adjacent list, or else it will keep the node in the queue as it was already visited. So now I will show the program. Yeah. Yeah, here we go. This is the program for BFS for the graph, which I have already shown in the first starting. So this is the best first search code in Java language. We have written. Have written. Yeah, here this is the output. Like I will. I think internet is very slow. Yeah. See, like here I have given the inputs of node A, S, J, D, and M. These are the starting nodes as the inputs I have given, and these are the outputs for all the BFS algorithm search. So here, if I change any alphabet to the nodes which I already have, let's consider now for this I have given node K as a starting node. Now let's see what is the output I'll be getting. So for node K, this is JDH. So now here I have inserted the value K for the K as a starting node, and this is the starting node and this is the ending node for K in the breadth first search algorithm. So this is how it works. Yeah. From here, the next part will be continuing by greedy best first search algorithm. The next person will continue. Thank you.
Greedy best search first search algorithm. Today we are discussing about greedy best search algorithm. Next slide. Yeah. In the greedy best search algorithm, it is always selects the path which appears best at the moment, and the greedy breadth search algorithm is a combination of depth first search and breadth first search algorithm. It uses heuristic function and search. With the help of breadth first search at each step, we can choose the most promising nodes. In the breadth first search algorithm, we can expand the nodes which is closest to the goal node, and minimum cost is estimated by heuristic function, and we are using fn equal to hn. Next slide. And the evaluation function is fn equal to hn, where hn is the estimation cost from the node n to the goal. And in the greedy search, it ignores the cost of the path that has already been transferred to reach n. Therefore, the solution given is not necessarily optimal. And then the next slide. And now we are discussing about the pseudocode of the greedy search, greedy best first search algorithm. In this, the step one is initializing the variables. In this, we are creating an empty list for visited nodes, and in second step, we are setting the start nodes as a current node. After that, initializing paths and set is an empty node. And in the step 2, we are check whether the node is empty or not, and then we are adding the node to the path. In the step 3, we are checking whether the next node is a goal node or not. the goal node is if the goal node is empty, then we are existing the program, and this is the end of the process, and the next slides are continued by Shiva Krishna.
Hello all, this is Shiv Krishna. I'm going to explain about the flowchart of a greedy breadth first search algorithm. As my friend Trinayana said earlier about it, the pseudocode. Now we will go deep into how this algorithm works. Here at first, we used a function named greedy BFS. It has three parameters as the input. The first one is the graph itself, the undirected graph that was shown in the first slide of this PowerPoint. The next parameter is the start node, and the last parameter is end node. At first, we are initializing the variables. These are creating a list, an empty list to store the traversed nodes, and setting the starting node as the current node, and taking an empty path so that we can append it and print it at the last. First, at the next step, the program checks whether the start node is empty or not. If the start node is empty, that is null, then the program ends here and exits the loop. So that's the end of the program. If the start node is something like if the start node is not null, then the program checks the graph and praises the list of nodes in it, and it goes through the first node, and after entering to the first node, it will check with the next node. It will calculate the cost from the node A to node B or node C. As the algorithm name itself is greedy, it will check for the shortest cost, including the heuristic function plus the shortest path. So whichever is lower, the algorithm goes to the next lowest path available. It doesn't care about the end node or the previous path. It doesn't even remember the path of the previous cost after a node is traversed. So like this, the iteration continues till the next node is empty, the goal node or not. If the next node is a goal node, that means that's the end of the graph. Then the program ends and appends all the traversed nodes and prints the output. Here are the sample outputs. When the input is A, the output will be A, B, Q, H, E, L, U, G. So in all the cases, the end node is G. As stated in the document, we have taken the end node as G in all the cases, and the starting nodes are A, Q, E, Y, and F at each iteration. Now I will show you a demo of the code, how this works. Yeah, for this project, we have used IntelliJ IDEA and Maven for compiling the project. When there are more than one Java file, we use some compilers like Maven to link all the files and get the correct output. So this is the test driver code. Here just we write lines for getting the input from the user and praising through the nodes and getting the output. This is the undirected graph module. Here the graph that we shown in the first slide is fed into this undirected graph.java. This generate graph of a function stores all the nodes and their heuristic costs and path length. So let's run this and test the output. It's asking user for the input of start node. Let's check with the node A. When we given A as the input, the path is A, B, Q, H, E, L, U, G. It will work for all the nodes of user choice. Now let us run again and check for another node. Suppose say Q. The path is QHELUG. Yes, there is no requirement of traversing through all the nodes of the graph. The algorithm just checks for the next available lowest cost node and traverse through that. So in all the cases, there won't be like all the nodes. It doesn't traverse through all the nodes. Greedy search algorithm may not be optimal, but all the time. But the purpose of this algorithm is to make sure that the output comes like the program completes within some specified time, like as fast as it can. So greedy first algorithm is used where there is a time constraint and we need an output. That's it. Now my friend Sandesh will continue about uniform cost search.
Okay. This is Sandesh, and today we're going to be talking about uniform cost search algorithm and its application for our own project. For uniform cost search algorithm is a form of uninformed search algorithm in which the direction from source node to the destination node is determined through the calculation of lowest possible distance of travel. In this algorithm, the nodes undergo extension based on the lowest distance of travel from one node to another. The uniform cost search algorithm utilizes priority queue for the process of determining the path of travel with addition of nodes into the priority queue. When the queue is not empty, the node with highest priority is dequeued from it, removed from it, and the process only stops when the node that is removed from the queue matches our destination node. So let's go for the algorithm rules. So our algorithm works by adding the source node to the priority queue, and then like it starts to explore all the nodes that is adjacent to the priority queue that we've determined. So we'll be performing this step as long as the queue is not empty. Remove the node with higher priority node. So basically from the queue, we're gonna be removing the node with highest priority. And in this case, it's the node that has the lowest distance cost from the node, from the queue. If the removed node matches with the goal node that we have defined, then like the algorithm is gonna stop since we've reached our destination. And in the end, we're gonna have a travel path that goes from the source node to destination node based on this algorithm. As you can see in the flowchart, so like the algorithm begins by determining nodes and distance cost, and then it determines the source node and the goal node, and then it creates a priority queue that begins with the source node that has distance cost as 0 since it's the source node. And then it starts exploring out the adjacent nodes from the queue. And if the queue is not empty, it removes node with highest priority from the queue, which is going to be the node that has the lowest distance cost. And the algorithm will only stop after the node is present in the destination. And then the algorithm stops, and we note the travel path. And now my friend Sai is gonna go through the code and show us the output.
Yeah, thanks, Sandesh, for explaining the how algorithm works. So I'm going to show how I am going to explain about the demo how this algorithm works. So we use Java as a programming language to create this uniform cost search. So as Sandesh explained, it basically works on priority queue. And so I have defined 5 functions here with the source node as a, q, e, y, f as defined in our task, and the goal node for each function will be the same. It is g. So initially I have mapped all these nodes to numbers from 0 to 19 so that we can work on these nodes. So from here, I will call this function uniform cost. So in this function, I have created an adjacent matrix for all these vertices starting from A to the ending node, and that is 19th road. So we will use for loop to to iterate over each vertex or each node in the matrix. And from here we will call this cost uniform cost sets algorithm, where our main logic is defined. So here we have defined the priority queue. Initially we will make the node initial vertex as source node. So that is, if we take an example of source node as A, so it will become the source node, and it will be the initial node. So it will enter into these while loops for the evaluation, and the adjacent nodes to this A node will get explored, and the node with least cost gets priority. And if the queue is if the queue is full, the node with less cost gets high priority, and it will be removed first. So in this way, if we reach the goal node, then our goal is done. So let's run this project and see how it works. And since the professor has defined to use this this hyphen as delimiter between this between the nodes, we use hyphen as delimiter, and we use string joiner to do that. So as you can see the output, the source nodes are A, Q, E, Y, and F, and the goal node is same in all cases. So if, in this first case, this is the least path, least cost path to travel from A to Z, from source node A to Z. And in the same way for all these nodes from Q to Z and E to Z, Y to D, and so on. So yeah, this is the working principle of uniform cost search, and the same is shown here in PPT, and that's it. And Nida is going to take over from here to explain A**'s local bin search.
In this slide, I'm gonna talk about A* search with local bin search. And it's actually this algorithm, it keeps track of the K instead of, excuse me, would you please stop the record? In this slide, I'm gonna talk about A* search with local bin search K2. This algorithm actually is working search and keep tracks of the K instead of keeping track of the one state. It starts with a set of K states that are generated at random. All K states successors are formed at each stage. The algorithm halts if any of this is a goal. Otherwise, it repeats the process of selecting the best successors from the entire list. And actually, this algorithm is working based on the greedy algorithm with smallest of heuristic function. And a local bin search maintains the K states at any given time. These states are created at random at first. Then objective function is used to compute the successors of these K states, and the algorithm will come to a halt if any of these successors is the maximum value of the objective function. And as you can see in this flowchart, in this algorithm, we need to insert the initial state as a starting node, which in this project was the A nodes, and then expand the nodes and generating successors. and then evaluate all the states by using greedy algorithms, and then generate all successes of K2 states and select and add them, the minimum of them. And then if we reach the goal, which in this project was the G goal, the project is gonna be done. Otherwise, this process is gonna be repeat and repeat to reach the goals. And next slide, Hassan is gonna talk about the codes and pseudocodes.
Okay, thank you, Neda. Nedal, we are talking about ASTER local search with Beam local search. Then Neda already talked about the algorithm and the flowchart. I am going to talk about the pseudocode. Here you can see that the pseudocode, here we will use the tool link, open list and close list, and then we will start searching. If we will find our goal node, then we will stop the searching. Otherwise, there will be else loop where we will try to find the goal. Try to find the goal node, and when we start, then a start node will explore the successor node, and it will take 2 successors, because there we put the value of k equal to, then it will go further away and explore all the successors. And if it find the goal node, then it will start. But if it not, then it will search all successors, and it will take only 2 which value is the low, and it will continue until it find the goal node. So I'm going to show the course. So I used Spring Suite tool to implemented my Java code. Here I use the array list, because if I use array, I can't add or remove item, but in array list there is flexibility to add or remove list. And here you can see that I here give the start node as A, and there is a goal node is G. So if I run the code from here, so you can see that it is just from A and goal node is G, and there are the shortest path it choose when it travel those successors. So that's all from my side. I think Sucharita will give the conclusion.
I would like to take this moment to thank to thank our Professor Dr. David Dye for guiding us all throughout the project, and for clearing all our doubts and giving us more knowledge through the quizzes and assignments as well as the project. And I would also like to thank all my team members for their valuable contribution and for their excellent team support. Thank you so much, guys. Thank you, Professor.
Thank you. Thanks,
guys.
everyone.
Thank you all.
Thank you.
Thank you, Professor.
Thank you all.